Okay students, welcome back. Now we are going to take up the next problem. The next problem is on tetrahedron. The earlier problem which I have done was hexahedron. It had 6 faces. All the 6 faces were cubes. were squares. Now what is tetrahedron? I'll show you the model here. This is a triangular pyramid. You can see the base. The base is a triangle and you have 3 lateral faces. All the 3 lateral faces are also triangles. This is in fact a triangular pyramid. Now what's the difference between a triangular pyramid and a tetrahedron? First of all, tetra means 4. So like a triangular pyramid, a tetrahedron also will have 4 faces. See, you can see 3 lateral faces here and then a base. Okay. So there are 4 faces and all of them are triangles. In a tetrahedron, all the 4 faces should be equilateral triangles. Okay. Did you find the difference between a triangular pyramid and a tetrahedron? The base should be an equilateral triangle. The lateral faces, all the lateral faces also should be equilateral triangles. So all the 4 faces will be equilateral triangles. In that case, it is called a tetrahedron. So a tetrahedron is nothing but a triangular pyramid with all the edges equal. In other words, if the base edge is equal to the slant edge, if the base edge of a pyramid is equal to the slant edge of the pyramid, then it is a tetrahedron. Okay, I can also show it on the sheet here. You can come to the sheet. See, this is a tetrahedron. Okay, just now I have shown the model. This is base edge and this is slant edge. If the base edge is equal to the slant edge in a triangular pyramid, then it becomes a tetrahedron. Okay, that's what I have written. In a triangular pyramid, if all the edges are equal, that means all the base edges should be equal, all the 3 base edges, and also the slant edge, then it is a tetrahedron. That's what I have written here. Side of base is equal to slant edge. Now we are going to take up a problem on this. I'll remove the sheet and go to the problem. This is the problem that you have. This is problem number 3.8, reference number 44 of drawing number 13. Okay. So a tetrahedron of 55 mm sides rests on one of its corners. So this becomes simple position 2. So a tetrahedron is similar to a pyramid. So whatever rules of visibility you have applied to a pyramid are applicable here also. And you are going to apply simple position 2 because it is resting with one of its corners, such that the edge containing that corner is inclined to HP at 50 degrees. This is the HP condition. Okay. When it is resting with a corner on HP, there will be a slant edge containing that corner. That should be drawn inclined at 50 degrees to HP. That is the HP condition. And the same edge is inclined at 30 degrees to VP. That is the VP condition. So the flow is like this: SP2 first, followed by HPC, followed by VPC. Okay. Now let me start drawing the XY line first. In SP2, we start by drawing the top view first, and here the top view is going to be a triangle. In fact, it is an equilateral triangle. Okay, and you should get a corner on the right side. So I will draw an equilateral triangle in the top view. Equilateral triangle, you know, the included edges are 60 degrees. The included angles are 60. The edge should be 55 mm. All the 3 edges, in fact. Just show for Now this is like a pyramid, as I said. So we are going to name the corners just by one point, just A, B, C. You won't get A1, B1, C1. Now let us find out the apex. To find the apex, you should find the center. For that we will draw perpendicular bisectors for any two edges. From the corner, connect it with the midpoint of opposite side. From this corner, connect with the midpoint of opposite side. Wherever they intersect, you get the center. That itself is the axis. Once you get the axis, what do? You have to connect the center with the corners which represent slant edges. This is important. When I am evaluating the assignments, some of the students are forgetting to draw these slant edges. It's important that you should connect them using solid lines, dark lines. So this completes the top view of a tetrahedron. Now we will draw the front view by projecting these points. Now drawing the top front view is important. How much height you should take is the question. Here you will get the axis. Now the question is, what is the height? The height is not known. You are given just one dimension, 55 mm. So can you tell me how much should I take the height? Let me name these corners. This is A dash, this is O1 dash, B dash visible, C dash in brackets. Now this is how you have to get the front view. You have three slant edges here, OA, OB and OC. It is the edge OA which is parallel to XY. So if you remember in your straight lines, there is one true length principle. If the top view of a line is parallel to XY, then its front view should be true length. This is one of the true length principle in projection of straight lines. So because OA is parallel to XY, its projection should become true length. In other words, the front view should be true length. OB and OC are not parallel to XY, so they will not be in their true length in the front view. It is the only edge OA, only slant edge OA that will be in its true length in the front view. And in a hexahedron, the slant edge is equal to the base edge. The base edge is 55. So the true length of OA in the front view will be 55. So take A dash as center, 55 mm as radius, cut this axis. This is O dash. So this dimension is 55. Same as what you have here. Now you can complete the front view. So only OA is in its true length, OB and OC are in their apparent length. You can mark the dimension for this as well. This has to be 55. So we don't know what is the height, that's not important for us. But this has to be 55. This height could be any dimension. We need not dimension it. Done. This is the front view. Of course the base has to be dark. Yes. So this is SP2. Now we are going to satisfy HP condition. What's the HP condition? The edge contained by this corner. A is the corner which you are going to keep on HP when you go to second step, and AO is the edge contained by that corner. The condition says that should be inclined to HP at 50 degrees. Yes, this is in its true length and you are given the true angle. Just rotate in this direction and draw this edge inclined at 50 degrees to HP. So I'll start by drawing a line inclined at 50 degrees to XY. This inclination should be 50. On that you can mark A dash, O dash. The same length, 55. Now you have to get this point B dash, C dash, okay, by drawing arcs. So this point is going to be B dash C dash. How are you going to get it? O dash to B dash C dash, this distance. You draw an arc, then A dash to B dash C dash, this distance. You cut it so that you get this view. Okay, so this angle is 50 degrees. Slightly I'll change this. Now I am marking O1 dash. This is the axis. Yes. So that completes the front view. Okay. So I'll repeat it what I have done just now. You have started by drawing a line inclined at 50 degrees. Okay. On that line you are going to mark this dimension. Point A you have to keep on HP. So take 55 mm and mark this here. Now you have to get this point B dash C dash. So A dash to B dash C dash, you draw an arc. O dash to B dash C dash, another arc. You get that point, you mark it. Now let us apply rules of visibility to this view to get the top view. The rules of visibility are similar to pyramids what you had. Now if you look at the base of the pyramid or the base of the tetrahedron, it is away from the observer. Apex is nearer, base is away. So the observer will not be able to view the base. So you cannot draw all the three base edges visible when you draw the top view. Let us draw the locus lines. Now this is point C, this is B, this is A. Let me project the apex also. Apex or the vertex. Here it should lie. Now let me draw the boundary. This is the boundary. Now because the base is away from the observer, only this edge is visible, the remaining two edges are invisible. So the connection also will be invisible. And you can finally project O1 dash down so that you can mark it here. So a little portion of the axis you will be able to show as a chain line. Only A to O1 you will be able to show as a chain line because the remaining portion is overlapped by the dotted line. Okay. In fact, O1 is the top view of the axis. This is O dash. Sorry, there is no dash. So O and then O1. So this completes the top view in the second step. Or in other words, we have satisfied the HP condition. Now let us move to the VP condition. The VP condition is given with reference to the same edge, OA. Okay. So you have OA here. Is OA in its true length? No. Because OA is inclined here, this can't be true. But what you are given is the true angle. It is given that edge is inclined to VP at 30 degrees. So you have a combination of true angle and apparent length of OA. So we need to find beta here and it should come to 51 degrees. So let us find beta. The true angle is given as 30 degrees. So let us start by drawing a line inclined at 30. And let us mark the true length of OA on that. The true length of OA is 55. Okay. So I'll call it as A1 dash. A1, that's all. This is 55. Now you have to draw the locus passing through A1 dash, the locus of A. Take this distance as radius, O to A. This is the length of the top view. Draw an arc. OA as center, OA as radius, you have drawn an arc that you can show as dotted line. It's already dotted. Now with this as one of the lines, you have to complete this view. Okay. Now let us extend this line down. A to O1, you can take the distance and mark O1. O1 to here, you can mark that distance as well and draw a perpendicular to the center line. On that perpendicular you can mark the points B and C. This is B, this is C. Now you can get the boundary. And then the dotted lines. So that completes the top view. Now let us move to the front view. This is the position of the observer, and this time the base is nearer to the observer, ABC. So when you draw the base in the front view, that should be drawn using solid lines. Now this is the projector passing through B and C, and XY line is the locus for A. So let me project A till here. This should be A dash. This is C, and then this is B. So this is B, this is C. I can draw all the edges solid. A dash, B dash, C dash. That is the base. Now let us project the apex and complete the boundary. This is O dash and this is the boundary. Okay. So you have OA, you have OB, and then OC you have to draw. Okay, as you can see, OC is away from observer. That won't be visible. OC is here. Okay, so OC you can draw dotted. And then finally the axis. This is O1 projected. Draw its locus. Draw its projector. So this is O1 dash, draw the axis, chain line. That's it. That completes the front view in the third step. Okay. So here the beta I have not shown. When you extend this line, this is beta, and beta should be 51 degrees. You need to find that angle. That's it, students. So this is also a special solid which is called tetrahedron. So tetra means 4. So tetrahedron is similar to a pyramid, whereas hexahedron is similar to a prism. So these are some special cases of prisms and pyramids. Okay. So I'll take a short break and come back again to solve the third problem. The third problem is on a cone. Okay. I'll come back and do that problem and then wind off solids with that. Okay. You can take a glance at this.